Hi everyone, I'm Stan Yoshinobu. I'm going to talk to you today about activating Polya's method via inquiry-based learning. So here's Polya's method. It's a four-step process, which I think is really important for students to engage in when they're learning mathematics or any subject. But let's go through this. So step one is understand the problem. So what is the question asking you to do? What is the thing that you're going for? What is the goal? All right, and then going on to devising a plan, so chipping away at what might work and trying things, and then carrying out the plan, and then looking back because you want to make sure that when you stop, you've got something, or how much of it did you solve, how much of it do you still need to solve, etc. So these all are wonderful high-level thinking things that everyone at this conference, that you understand and you're really supportive of. So where inquiry-based learning comes into play is, well, how do you get this idea, this problem-solving process into your classrooms? And what I mean by classrooms, I mean any level. It's K through college or graduate school. I believe, my personal belief, is that you can implement this at any level, and that we should be implementing Polya's method and problem solving at all levels, because that's really what the heart of the matter is, right? Learning how to think and problem solve and deal with being stuck and collaborating with people to get to a better solution and so forth. So all those things that we really enjoy about actually doing mathematics. So let's talk about the inquiry-based learning framework. So the IBL framework has 4 pillars now that have been derived out of the research. So number 1 is deep engagement in rich mathematics. So that's a key thing. And then that's connected to problem solving, obviously. Like if it's a simple, trivial problem, that's not problem solving. So you need rich mathematics, and students need to be deeply engaged in the mathematics. The second pillar is opportunities to collaborate in some form. It could be a student presenting their idea for peer review to the whole class. It could be what we typically think of as collaborative learning, where students are working in groups to develop ideas or devising a plan or carrying out a plan. So that needs to be there because it's talking about the problems, and the problem solving process is what often helps students make sense of what's going on, right? They just can't sit there and think. They also need to talk about it. Say, well, I wonder about this. I wonder if we tried p equals 3, what happens in that case? And that is supported through a discussion, and hence you need some collaboration. The third pillar is instructor inquiry into student thinking. So this is where the instructor is monitoring what's going on in the class and thinking about, oh, I think my students get this part, but they're struggling with this next piece. And that's where the instructor can gather data and information about their students and then use that for their next teaching step. The fourth pillar is an instructor focus on equity. So this is important. So equity means it's meant in a very broad sense. So making sure that all students are engaged, that students have access to support. It also means attending to students from groups who have been traditionally not included in mathematics. So making sure that we're leveling the playing field. So those are the 4 main pillars, the 4 pillars of inquiry-based learning. And what we believe is going on is that in an IBL class, that we're creating problem-solving environments that support student learning. So, and we mean this in a deep sense. So obviously you have to have problems, you have to have good content, good instructor skills, but also all students feel like they have agency, that they have a role to play, that they feel like their needs will be attended to, and that if they have something to share, an idea, that they get to share it. So in that sense, that 4th pillar, that being included, is important there in creating that safe problem-solving environment that's supporting all the students. All right, so let's take a look at some pictures. So you have here, you have the instructor is talking to a student here, and he has problems placed on the board. These are actually different problems, and he just selects students to go and work in pairs with each other. So it's a way to engage, like, okay, here are some problems. Let's work on them together. And other forms of inquiry-based learning, you can also see students go home with a problem set, and then volunteers are selected to share their solutions. And then one by one, they go up and they present their ideas to their classmates, and then their classmates will offer suggestions, offer corrections, or compliments, and say, oh yeah, I did the same thing, or I really like what you tried, but also maybe we need to rewrite that third line just to make it absolutely sharp. So that kind of collaboration. So this is a typical inquiry-based learning course where students are presenting their ideas, but we also have other cases where students are working in groups, and you have the instructor here giving the students a task on a piece of paper, and then they work together on a whiteboard to make sense of what's going on. And so that's another way to get students to engage deeply in mathematics. All right, and so we also see this, you can apply it in stats. So this is Professor Matt Jones at Cal State Dominguez Hills, and he's teaching an introductory statistics course. And he's having his students work through, okay, here's a scenario, what's going on, what is one of these things? So it's like kind of early problem solving steps. So I also want to say that problem solving doesn't have to be giant, massive problems all the time. If you have students who are taking courses that are, say, support courses for a first year stats course, they're not at a point where they're going to, prove the extreme value theorem, right? Obviously. So I think it's also important to think about the size of the problem in relation to where your students are at and what they're coming in with. And then you can think of it as a developmental progression, and we can get students to that Polya method by starting with where they're at and then building them up over time through all our courses. So you don't have to just think like, well, I can only do Polya with the math majors. I can also find ways to create an on-ramp for students to get exposure to some of these ideas at an earlier phase so that we can build them up so that they can get there at, eventually. All right, so I just want to share that. All right, so how do you get started? First thing you can do, and you can do this term, this term, you don't have to change everything, is if you haven't tried this yet, one thing to do is just to carve out time in your course for problem solving, and you can do that in a number of ways. You could use flipped learning. You can cull some topics and emphasize them a little less, and then use mini lectures to cover them. And then you've bought yourself 20 minutes. That's a great time to say, okay, let's work on this problem together for the next 20 minutes. See, so you can build time. Reading assignments, I think, are really handy, where you can get students to have a first touch on, say, definitions that are coming up before they come to class. That might save you some time. So think about ways to buy time in class, and then you can put the problem-solving experiences throughout the term. Another thing to do to get started, if you've never done any active learning, is to try Think, Pair, Share. I think this is step one, and it's a great step one because you don't have to change your teaching philosophy all at once in one giant step. And you can just say, okay, here's my interactive lecture. I'm going to pose a question. I'm going to have students think about it, then talk to a partner, and then we'll have some kind of sharing where either I'll go through it as the instructor, or I can talk to a couple of pairs and have a student chime in and say, okay, this is what we came up with. So that's a way to get going. It's not the last step, it's the first step, but it's a way to get going so that you can make a plan for yourself as a teacher to get to where you want to get to. Further steps is that you can go to MAA conferences, also AMS conferences, have some sessions at the big meetings where there are workshops or sessions on inquiry-based learning, so you can find out about it there. And also there's our website, the Academy of Inquiry-Based Learning. We have a bunch of materials and support for college math instructors who are interested in IBL. So that's it from San Luis Obispo. I hope you're having a great time and learning a lot and sharing a lot, and I wish you all the best. All right, thank you. Bye-bye.